Hi there, can you guys hear me? Great, all right. So my name's Gavan Wihite, and I'm here to talk to you guys today about holograms. And when I'm talking about holograms, I am talking about the sci-fi kind of holograms. So the Star Wars kind of holograms where you have like a scanned person or a 3D object there in front of you. The her-style holograms where you have these like cute characters with room-scale video games that look like they're there in front of you. And yes, of course, the possibly not very practical but awesome user interfaces like in Iron Man. And it sounds kind of crazy, but these things are being built today. And they're being built using technologies like VR and like AR, where you can actually be immersed in these worlds, and we can literally address all of the pixels around you in such a way where we can make these technologies exist in a virtual world where they do not actually exist in the real world. We don't have holographic projectors yet that work at any kind of capacity, but we have these types of devices that you can use to start rendering this holographic content. So I just need to give you guys a tiny bit of context here before I start. So around 2 years ago, me and my co-founder met and started working on a company called AltspaceVR. And the goal of this company is to let people communicate online in the most natural way possible. So the idea is that we're going to use these VR devices, let people put them on, and then you can have a conversation in a room with people who are all inside of virtual reality. So we have a company down in Redwood City. There's a couple dozen of us. And this is what things look like right now. So this is one of my favorite GIFs, because we have our eye trackers implemented here. And you basically have this robot avatar that you can use to talk to other people inside this space. It's especially useful when you have a dozen or so people, because it's really natural to just walk over and start talking to them. So we built this thing, but we realized that people really, and we built in basic web browsers so you can go watch YouTube on a big screen. You can interact with Google Docs and things like that. But people really wanted these holograms. They wanted to have these 3D applications in these spaces while they were there together that they can work with right in front of them. And funnily enough, I was thinking back to it when we were doing this. This was right after I went to HTML5DevConf like 2 years ago. So all these web ideas were fresh in my head. And so we started thinking, can we use the web for these sorts of things? So in thinking about it, the web has a bunch of really nice properties for sort of serving applications. It's got a great sandbox. It has this sort of built-in delivery system with URLs where you hit a URL and it starts downloading content. You have really neat things like live IDEs that are built into web pages. You have this fantastic open source community. And you have this really interesting place where you have open source and open 3D content. You have lots of 3D content on different platforms. But this is one of the few where you do have a fair amount of open source 3D content, which is really neat. So we spent some time in the cave and we built some things, and well, we ended up merging the web and holograms together, and this is what we ended up with. So that's a Nyan cat, which is very loud, and I'm sorry for blowing out your eardrums. But so this is an internet meme. This is a Three.js application that someone had built. And it took us a couple hours basically to take this and import it into virtual reality. And now you have this application where you can actually walk into this thing and sort of be in the midst of the sparkles. And this is something that's really easy to create, and it really got us excited. So I'll show you one more example here just to explore the different aspects of it. So this is an application that we call Flappy Dragon. You guys might see some similarities with some mobile games that have come out. But basically the idea is you click on the grass there, and it makes this guy jump. And when you click on the logs, they'll move up and down, and you can sort of use this to lay out an interesting sort of maze. And so this is a web page. You hit this with a URL, and it loads up. But it's here in the scene with you, which is really interesting. And you can interact with it in a very 3D way, and you can walk around it inside of virtual reality. So there's three main things that go into making this happen. So the first is rendering. You need to be able to render this stuff inside of the world, inside of the headset. And so with rendering, you need to have true 3D objects, and they need to be viewable from all angles. So we can't use a lot of hacks that people have done in the past. These actually do need to be meshes or point clouds or something like that. And I need to be able to sort of get down inside of them and really walk around them from all angles. And then the last point is really important, that it has to be composable with other content. So it has to be correctly depth sorted and blended so that if I have a tracked hand and I sort of stick my hand in between the content, it'll actually go like in front and behind the content. If I was to walk around outside of this room here and look in through the window, the window should render on top of it. So these are the sorts of issues that you have to start solving with these things. We have to look at input. So the browser has some really nice things around mouse events, but they don't really translate very well into 3D. But you can make things that are sort of spiritual successors or very, very similar to what you would have in the browser. So in this case, you can see that he's sort of moving this cursor around the scene. And what that's doing is that's taking his sort of mouse movements and projecting it out as sort of a raycast from between his eyes out into the environment. And we represent most devices like that. You can do that with motion controllers and a number of other pointing devices. But you basically need some way of interacting with a normal input device into these virtual worlds. And then with skeletal tracking, often what you need is you really want to be able to get your body into this experience. So you want to be able to sort of reach in with your hands and grab stuff. You want to have these characters. Like it'd be really nice if once he fell, he sort of looked at you all sad, right? You want him to be able to know where your face is when you're inside of these virtual reality headsets. And then the last point, it's sort of a subtle one, but once you're in there, we're so used to these glowing rectangles for our devices that are very sort of personal devices. My phone is here, I'm the only one seeing it. My laptop is here, I'm the only one seeing it. But when you have these holograms that are out the size of a table or the size of a room, you really, really want other people to be there with you. And so you need to have other people being able to see what you're seeing. And this is not something that we get by default with the web. You really have to go, you have to put in a lot of effort to make sure that two people can be looking at exactly the same thing at the same time. So I'll talk a little bit about our implementation and how we made this work. So there's really three main components here. So we chose Three.js as the engine that we were going to implement. We put it on top of a Chromium implementation that we have, and we basically bake that inside of our virtual reality client. So for us, that's the AltspaceVR application. But if other people were trying to implement a similar sort of thing, you basically need some kind of game engine there at the bottom. Or at least that's the easiest way of doing it. And the nice thing about it being Chromium is all of your normal web features, your audio tags, all that kind of stuff is just going to work. It's basically like you're writing it to Chrome. And one of my guilty pleasures here is that I no longer have to deal, when I'm writing Altspace apps, I never have to worry about cross-browser compatibility anymore. So once the ecosystem gets a little bit bigger, that might change. But that's nice for now. So these are the sort of subcomponents that we had to look at here. So we needed some kind of 3D window system, because in a normal browser, you have the DOM and you have the window system, but they only have like an inner height and an inner width property. They don't really support 3D content. We had to build a Three.js renderer. We had to provide some input APIs, and then for synchronization, we built some wrapper libraries around Firebase. It was the easiest way to get started, and it tends to work pretty well. So we have these 3D windows. We call them enclosures, but they are pretty much just 3D windows. And I have just some pseudocode down there, so you can see a little bit how it looks. But you basically, we have what essentially is a window, but it both has an inner height, an inner width, and now an inner depth property. And those values are still in CSS pixels, which is nice. And it's kind of interesting because CSS pixels, it was a little bit frustrating because they weren't actually pixels for a while, or they still are not. But it gives them an interesting property where they're sort of these arbitrary units, and it basically came when we had high DPI screens, right? They didn't map one-to-one anymore. But now they're these arbitrary units, and so what we did is we basically took Three.js, and we took the units in Three.js and just mapped them straight onto CSS pixels. So, and that works pretty well with most gaming engines. Most gaming engines have arbitrary units anyway, so works pretty well there. And then I want to call your attention to the scale property down there, which is really nice. So this gives a pixels to meter ratio, which is really useful because there's a lot of times on the web where you want to have like life scale objects or life scale content. I want to show you what the actual size of this thing is. But normally in a browser, you can't really figure out how big the user's monitor is in a consistent way. And so there's no way to actually do scale objects. But when we have these browsers in the virtual world, we know how big they are. So we can actually give you a value so you can make like life scale objects. You can even do it on 2D web pages by doing that. So that's fun. So as I said, we basically wrote a renderer for Three.js. So for those of you who are not familiar, so Three.js is it's a 3D engine or a 3D rendering engine for JavaScript. It renders out normally to WebGL, but it can also render to a whole bunch of other things. So it can render out to the DOM, it can render out to straight canvas. It has some kind of fancy software renderer. But the neat thing is that it is render agnostic, which is pretty rare for a 3D engine. And so what we did is we basically just implemented our own renderer. And the way that these renderers work is you basically give them your scene graph, and they display it in some way, shape, or form. So we're able to do a very similar thing in virtual reality. And some people will ask, why didn't you just support arbitrary WebGL, so we could use whatever JavaScript engine that we wanted? And there might be some ways that we can do that in the future. But one of the things that's really difficult is you really, really need to know some semantic information about the objects to give a good experience right now. So for example, with those cursor inputs, how I was like clicking on those blocks to make them go up or down? You really want to be listening to those events as just, what is my cursor up event happening on which object? You don't want to be getting the raycast and having to do all that stuff internally. You just want to know, what is the user clicking on? And in order to do that, you need to have knowledge about what the 3D objects are in the scene. You can't just be taking sort of raw WebGL pixels that are being exported. It's sort of a comparison between DOM objects and a canvas, where we wanted more DOM objects and less sort of canvas, if that makes sense. One extra thing to note here at the bottom is you don't pass in a camera. If you're familiar with Three.js, normally you would render this with a scene and a camera. But in VR, basically the virtual cameras are where the user's eyes are. And you're not allowed to really move that around because the user is allowed to move around in space. So basically the browser takes care of where the cameras are in this case. To give you a little bit of a sense of how this renderer works, essentially what we're doing, and so the Altspace client, it's a native application. It's written in Unity. And so you can think of it sort of like the browser, or at least it has a browser inside of it. And so what we're doing is we're essentially taking Three.js objects, these sort of 3D JavaScript objects that would normally be rendered to WebGL, and instead sort of piping them into the game engine and representing them as game objects, so you sort of Unity game objects. And we're copying over sort of the three main things that you need, which is the transformations, so that's the position, rotation, and scale. The geometries, so what is the shape of the mesh, what are the UV coordinates, these types of things, and what are the materials that it has. And so right now our renderer is pretty basic. There's no lighting, and the material support is basically just like unlit textured materials. But the nice thing is, since we have the Three.js WebGL renderer as a sort of proof of concept, and that people have sort of optimized that towards a feature set that they want, we have a pretty good path to get up to that level and sort of keep implementing those WebGL features that exist for Three.js. As far as sync, we basically wrote a utility that can take a Three.js scene graph and synchronize arbitrary properties of those objects. So things like position, rotation, scale, those are usually the most important things that you want. But oftentimes you also want things like high scores. And so Firebase is a great way of doing that, and we just have some simple libraries that wrap around that. Talking about input real fast. So with input, we want that ray-based cursor so that we can basically take arbitrary input devices and treat them the same. We will have to have a solution for 6 DOF controllers, your like sort of motion controllers where we can reach out and grab stuff later. But right now the ray-based cursor basically works across the board. Even if you don't have an input device, you can use sort of the head angle to do like a ray-based cursor from the eyes, and that tends to work pretty well. As far as the tracking skeleton, like I said, you want to know where the user's body parts are a lot of the time. And so what we did here is we've been playing with this concept of sort of symbolic objects where you'll sort of request something from us and we'll hand you back a representation as a Three.js object that has some sort of special properties. So in this, you'll see I'm doing altspace.get Three.js tracking skeleton. And what happens there is we hand you back a hierarchy of Three.js objects. And those objects are basically mapped to the joints in the human body. And basically, the browser will automatically update the positions of those to match whatever sensor inputs we're getting from, say, a Leap Motion or a Microsoft Kinect or whatever device you happen to have attached to your computer. And so it basically makes it as easy as just sort of taking your object that you want and parenting it under that skeletal object that you receive. If you want to, say, like attach a holographic display to someone's wrist for like a virtual wearable device, Or if you want to have like a HUD that follows them, you can just sort of parent your HUD underneath their center eye. You shouldn't do that because it makes them sick if you do that. But you can sort of parent that under your head and it'll follow with you. So, as we were building this stuff, there was 2 places where we found that it would be really useful to have some more features in Three.js. So the 2 that really stood out was event bubbling and behaviors. So event bubbling, as many of you might be familiar in the browser, is basically when you have an event that happens and you want it to sort of walk up the hierarchy of elements. And what an example might be in a 3D application is, let's say you have sort of like a button that's hovering out there, but that button is made out of like a bunch of different sort of like flat sprites. So maybe it's got like a border and it's got like a sprite inside of it. And that event is going to happen on one of those sprites, but you really want to attach that event listener to the button itself, right? You don't care which of the sprites is clicked on. So it's a simple thing that most browsers have, but Three.js didn't. So we wrote a shim for bubbling of events in Three.js, and hopefully we'll be releasing that in the next couple of weeks here to the community. This is one that I'm really excited about. So Three.js is a great solution for sort of rendering 3D content. But it doesn't call itself a game engine. It's not a game engine. And it doesn't have a lot of the things that you would normally associate with a game engine. And there's a number of things like physics and audio and stuff like that that would be nice to have, but you don't really need. But one of the things that you really do want is you want a consistent way, a consistent game object model, a consistent way for people to write scripts so that they can sort of share them and use them on different projects. And you want people to have this like mental model that the objects are the first class thing. The 3D objects are the things that they really care about. And so what we did is we wrote this behavior system, and this will probably look familiar if you've used a gaming engine like Unity. But what it allows you to do, and actually I really hope somebody does this for the DOM also. I don't really know why it hasn't been done yet. But it basically allows you to attach scripts to your 3D objects so that you can basically take, so this is like a spin behavior. So you can sort of like attach a spinning behavior to your 3D object, and it'll just start spinning. And then you can also take like a drag behavior and attach it to that as also. And now it's spinning, but you can also drag it around, right? So it allows you to sort of arbitrarily attach behaviors. Really useful for AI systems, really useful for user interfaces. And you basically just have to return an object that has these sort of duck type functions where it's got an awake and an update. The most important of which being an update, which is sort of called roughly every request animation frame. So basically all your behaviors sort of update at once. So just some points to remember as I'm going over this. So this can both be made to make new applications, but it can also be used to enhance existing websites. So say, for example, you're an online retailer and you have a preview window up in the upper left corner of your product. Well, you might, if you're being modern about things, you might have had sort of 3D scans made of your products. And you might have like a WebGL viewer right there, a Three.js viewer for your product. So if you just simply swap out that renderer once you're in VR, all of a sudden that preview is now a holographic object that you can look around inside the web page. So you can do these sorts of things as well as sort of building full applications. An important point to think about this is most VR content right now and most holographic content is distributed just by like emailing people EXEs, or it's in these sort of closed app stores. This, and something that I'm excited about a holographic web, is that you can host it anywhere. You know, it's that sort of Wild West. It's one of those things that we really appreciate about the web is that there's no filters. There's no gatekeepers. So you basically host this content anywhere, and it just hit it with a URL. And then the last point is that it's multi-platform. So you can literally have the same game running inside of VR, like holographic chess, say. So I'm inside of VR, and I have this holographic chessboard in front of me, and I can pick up and move the pieces. And I can literally be playing with somebody using the same code on their cell phone, right? Because WebGL works on cell phones now. And so this stuff can be completely cross-device, which is very, very good. So at this point, I was going to switch over to Altspace, but we had some technical difficulties. So I'll show you some GIFs, which should hopefully fill in here. So this is one of the really neat things you can do with this. So this is inside of Altspace. These are sort of web browsers that I have around me. And I'm using CodePen here, which is a great online IDE. And that 3D object, that blue cube, is a holographic object in the scene. And so I can live edit the code that's powering this cube in CodePen, and it'll just automatically update. So this really reduces the sort of like Alt-tab away, like change some code, or like, God forbid, like recompile the thing and see how it's going to work in VR. Now you can just sort of do it. And In this example, I am actually wearing a headset at the time and live editing it. With the current dev kits, the resolution isn't quite there, but it's nice that you can at least do it inside the same browser. And also as the headsets get out, especially just these new commercial versions that are coming out next year, it'll probably be good enough where you can start to do these sorts of things. Oh, this is showing off sort of synchronizing the thing. So I'm taking it from my sort of personal browser there and putting it in the world. This is my friend Bruce, and so he's just sort of showing that he can see it up there. And so this is what you can do with the content to basically let other people see it. This is a fun one just to show how to get around some of the limitations that we have. So this is a fun little Space Invaders type game that somebody built. And he really wanted to have those sort of wiggly tails. And we don't have support for sort of soft body animations yet, so we basically just took a whole bunch of spheres and like made them move so they look like soft tails. But the end result is actually pretty sweet. This again, someone getting around some limitations. We don't have any particle system support in Three.js, or we don't support the built-in ones. But he basically built his own here, and even sort of faked some of the transparency to a certain extent. So this is a fun one. That it's sort of like a multiplayer Tron game. And my favorite. I'm a big Dungeons and Dragons fan. So somebody built a holographic application for playing tabletop RPGs inside of VR. So you can literally sit there with a whole bunch of buddies around the country, wear these VR headsets, and play Dungeons and Dragons at the same time. And I'm super excited about these sorts of things when they're open source, and we can just start like forking them and having different sort of tabletop RPGs that are all based on the same code base. All right, so it seems like the future, but sort of where do we go from here? So I think there's sort of three main things. The first is we just need to build lots of these things. It's really hard to tell like what APIs you need, and like especially what standards to make until we have a whole bunch of examples of things to see what they need to be created. Once we have that, then we can start improving these APIs. And I'm really excited to start collaborating with other people who are doing similar work. I know there's a few companies out there that have been doing this. It's all in the very early stages, but once we're able to hit these three items, I really hope we can start building some standards around this stuff. There's a ton of work left to do. I could talk about this for hours. Everything from integrating the DOM more closely to being able to like find out what's in the environment to getting better lighting and shading in physics and stuff like that. So really, really exciting stuff to come. And I just want to say, I really do think that we need to do this in some way, shape, or form. We all love the web. That's why we're here. And I worry that VR is extremely both performance intensive and also performance sensitive. So if you drop any frames when you're rendering these things, and you have to be rendering at 90 frames per second in stereo, which is insane, it basically completely breaks the experience and makes people nauseous. So you know how people are sensitive to like scrolling on cell phones? Well, this is even worse. And so we have to spend a lot of effort and really work hard to make sure that this works well with the web, because it's never going to be quite as fast as native, but we can do a lot of really good things to make it there. And so I think if we don't, we're going to be in a world where just all these VR experiences are native experiences. And they'll be great, they'll be entertaining, but they'll always be behind these closed app stores. And I really think there's an imperative to do this. So on how to get started, if you visit developer.allvr.com, we got a bunch of resources on this stuff. Start building holograms. And if you want to work with us, we're constantly hiring. So thank you very much. Got a question? Yep. Yeah, I've talked with them a couple times, but we're not working together in any official capacity yet. Okay. Cool. Are there questions? Yep. So are we releasing APIs? Was that the question? Yeah. Yeah, so I'll tell you a little bit about what you'll find at that site. So we have basically like a minified library called AltspaceJS that gives you wrappers around a lot of the APIs that we have. So specifically like the rendering stuff, some of the input things. And they are going to be hooking into sort of like new browser APIs that we have, like the Git skeletal trackers and Git enclosure. And so these are new APIs that we've built into our web browser. And so you'll get documentation on how to use that and also sort of helper utilities to make that happen. Yeah, definitely. Any other questions? Yeah.
So it's more you have like a 3D browser for exe, not something that is.
Right. Yeah. So we are. There's no. Yes. So we are a desktop application or a mobile application that is a VR application. So you'll run it, you'll put on a headset, and then you'll be inside there. So yes, it is another browser, so to speak, but it's using Chromium internally.
And for that question, so you would host your VR experience similar to a website, and your browser would download it. So go to www or whatever, and just download it with expecting your DOM and your JavaScript API.
Right, so basically you can just do a feature check like you would normally do a feature check in a browser for these VR specific features that we have. And then if you saw those, then you could render VR specific content. Yeah. Yeah. Cool. Yep.
Can you talk a little bit about the multiplayer apps that plays out in latency?
Yeah. So multiplayer stuff. So latency is always an issue, and we're using Firebase, so I think that's all over TCP. So there is a couple hundred milliseconds of latency. It really depends on the design of the experiences that we're doing. So for like chess, it doesn't matter so much, and if you're sort of doing interpolation between the positions, it ends up working out okay. So what you have to be doing, and I'll tell you a little bit more details about how it actually works in this. And so all that AltspaceVR is doing in order to synchronize stuff is making sure that if I'm looking at a holographic app here, it's the same URL that you're seeing. And so what we'll do usually to synchronize these experiences is we'll sort of append a instance ID as a query parameter on the end of the URL. And then both apps will know that it's pointing at like this specific instance. And so they'll connect to the same Firebase instance. And then those positions will all be synchronized on there, if that makes sense. And so you could also use, like if you wanted to make your own WebSocket server for this, you totally could. You just always need some sort of like room ID to know what sort of like instance of the application they're looking at. Does that answer the question, or?
We're getting there.
Okay, or we can also talk afterwards. Yeah. Awesome. Yep.
More on the multiplayer. Would you need to build a server host system to host those online games multiple players?
Right, so there's a number of different ways you can tackle this problem. You could do a peer-to-peer solution with WebRTC or something like that. That doesn't scale up past a certain number of players super well, but you could totally do it. When we're using Firebase, that's like a platform as a service. So it's sort of hosted on their own servers. And in that case, you do need to also sort of do some master client type stuff if you want to have one person controlling the scoreboard or something like that. You could also do it more like a traditional multiplayer game would with having like a dedicated server that's running Node.js or something like that. That's keeping the internal game state. Those would all be different options for doing this. Yep.
Do you anticipate VR becoming mainstream as well?
Oh, sure. Yeah. So the question was, do we anticipate VR becoming mainstream? So yeah, I actually have a device somewhere here. Yeah, so these things are coming out in the next couple months. So this is a Gear VR headset, if anybody hasn't seen it. So this is a device made by Samsung and Oculus. So it basically uses any of the new Galaxy models that came out this year. And so, I don't know, it's some hundreds of millions of headsets. What's that? Note 4? Yeah, it uses the Note 4, and the new one's going to use like S6 and S6 Edge, and basically all the ones that came out this year. So that's one that we're super excited about. We have that in alpha, but all the other VR headsets are coming out early next year, and those are going to be very gamer focused. So this year with this release is sort of wide consumer market, but it's lower power because it's on a cell phone. It's a little bit trickier to write applications for it. But those will hopefully be in many millions of people's hands. And then next year with the gaming markets, I'm expecting similar sort of numbers. So, but again, don't quote me, it's all speculation at this point. But yeah, that's what we're looking at. Yep.
What kind of optimization you made to the Three.js to make sure it's working smoothly on the mobile?
We have not actually gotten it working on mobile yet. So yeah, I will say that one of the things that we are able to do is we're able to cheat a little bit in the fact that we're moving these things into Unity, so we have them as game objects. So we can do things like reduce the update rate in JavaScript to like say 30 frames per second, but then sort of like interpolate it in the gaming engine so it still looks smooth, but it's not actually running at the same update frequency that you might have in a normal browser. So we can do things like that. Yep. Yep.
You call your app in a browser.
Yeah.
How does it handle navigation by basically typing in URL and then have things like tabs or representation like you have?
Yeah. Let me go back to that slide here. Oh, one fun thing is this presentation can actually run inside of AltspaceVR. I wasn't able to do it at this time, but it's fun because you can do that. You can also have holographic objects in your slides because this is using Reveal.js. So lots of fun things you can do. Right, so you'll notice down there's a URL bar at the bottom. And we got like back forward buttons down there. We don't really have tab support yet. That's one of the features that we're working on. But you can see that we have sort of multiple browser windows open around us. And when you sort of move it into that sort of synchronized area that's in the middle with everybody, there is no like address bar on there right now. That's something that we're adding. But that is still like a browser window. It just has sort of that toolbar hidden in there. If that makes sense. Does that answer your question? Or yeah, cool. Any more? Yep.
You might have answered this during your presentation, but I missed it. Are you working towards standardization for this type of thing in browsers?
Yeah, so it's something that I'm definitely interested in. There hasn't really been much work on that so far because most of this is just like, let's build it and see if it works. One of the things that we have been doing sort of in that mindset is basing it off of Three.js. So we decided early on to try to use a open source JavaScript library that a lot of people were using because we sort of had to pick one for some of those reasons that I was going over before. So I would actually be interested in exploring whether Three.js or something similar could be turned into a browser standard because it's used so much and because it actually has some pretty well thought out design principles. But that's about as far as we've gotten so far. Yeah. Cool. Anything else? All right, well, I'll be here afterwards if you want to talk to me about any of this stuff, if you're interested in working in VR, and thank you guys so much.